Welcome to my YouTube channel. Today I brought you the very simple question and very important, very good questions from the convection units. So this problem belongs to the free convection. Why I am telling this free convection? Because your velocity not given in this question. Suppose velocity not given, this question belongs to the free convection problem. So now how to solve? These are the steps already I wrote and already so many video I discussed. First steps will be we'll see velocity given, not given. So free convection problem. Then we'll find the film temperature. Then we'll find the coefficient of thermal expansion. Then we'll find the Grashof number. This all formula will be there in the HMT data book. Then we'll find the product of the GRPR, Prandtl number. And we'll see the status of the fluid, either laminar or turbulent. Based on this laminar flow means this is the Nusselt number, turbulent flow now this is the Nusselt number. Then we'll find the heat transfer. So that is the steps here. So okay. So first film temperature we'll find and the property of the air we'll see from the HMT data book. First work is here. So what is the solutions here? First a vertical pipe. Before we solve some questions vertical plate. Now this is the pipe and per unit length of the pipe given. That means length will be there, vertical plate will be there means area we are finding width into length, that is called area. Here what is the difference? Previous question, some questions we did vertical plate and vertical pipe. Vertical plate na area will be W into L. If vertical pipe na area will be pi dl. Area will be pi dl. That will be the difference. All other things will be same steps we are going to follow. Okay. So you have to careful. One problem they given vertical pipe or vertical plate. If horizontal plate, that will be different method. That also I will solve. So now this question is vertical pipe. So only area will be different. Pi dl will come. So that we will see in the once we will solve the question. So first our work is find the film temperature. Film temperature nothing but TW plus T infinity by 2. So TW is given 120, then 20. 120 plus 20 by 2, 140, so 70 degrees Celsius. Based on the 70 degrees Celsius, we will find the properties of the air. Properties are nothing but density, kinematic viscosity, Prandtl number, thermal conductivity. These are the we'll find. So based on this, we'll HMT data book will see 70 degree HMT data book density will be 1.029. 1.029 unit will be kg per meter cube. If we'll see the kinematic viscosity at 70 degree from the HMT data book 20.02 into 10 power minus 6 meter square per second. Meter square per second. Then Prandtl number will be 0.6 something will be the 694. 694. These all will be the HMT data book. As page number like 42, 43 in according to the additions of the HMT data book. Then one more thermal conductivity K. Thermal conductivity K value will be 0.029. 0.02966 watt meter Kelvin. This is the unit. So what is the beauty for this heat transfer problem? Everything will be in the data book. Only you should know the process. So film temperature we find it. Based on this film temperature from the HMT data book, properties of air I wrote. Then what will go? Will go the coefficient of thermal expansion beta, because this is free convection problem. So we have to go to beta. Beta is nothing but coefficient of thermal expansion. This is nothing but 1 by film temperature. That should be in the Kelvin. This should be in Kelvin. So 1 by 70 plus 273. Just wait. 120 into 70, yes. So this will be 70 plus 273. How much coming? 2.91. 2.91 into 10 power minus 3 per degree Kelvin. 2.91 10 power minus 3 degree Kelvin. So this is the beta. Now we'll go the Grashof number. Beta we are finding because Grashof number beta formula will be there. So we'll go the Grashof number. What is the formula I am writing again here? G beta L cube delta V by nu square. So 9.81, this is value of the 9.81, 2.91, this value will be beta value 2.91 into 2.91 into beta value here, yes, into 2.91 into 10 power minus 3. The length how much given? 2.5 meter. This meter, centimeter we have to check. So meter power 3 into 120 minus 20 because delta T value. Then already kinetic viscosity value we know. 20 minus 0.2 into 10 power minus 6 whole square. So now GR value will know. GR value already we calculated, so we know the GR value 9.81 is there, 2.91, 2.5 cube. So 10 power 6 whole square, so 1.11 into 10 power 11. 1.11 into 10 power 11. Now we'll go the product of the GRPR. Product of the GRPR. So product 1.11 into 10 power 11 into 0.694. So this product we are getting how much? Product we are getting 7.72. 7.72 into 10 power 10. 10 power 10. So this value is coming more than 10 power 9. So this flow is turbulent. This is the status of the fluid because it is getting greater than 10 power 9. GRPR value, you write here GRPR value we are getting greater than 10 power 9. So this is the turbulent flow. Now based on this turbulent flow, what is the Nusselt number? Nusselt number will be 0.10 GRPR then power 0.333. This we wrote. See this for laminar flow, this is the Nusselt number. Turbulent flow, this is the Nusselt number. This all the value will be there in the HMT data book. So now we'll substitute this value here. Where substitute 0.10 GRPR, this direct value will write 7.72 into 10 power 10. GRPR 0.333. So this is Nusselt number we are getting how much here? Nusselt number we are getting 7.7 to 10 power 10. So 422.3. 422.3 we are getting. Now we know that Nusselt number is equal to HL by K. So H coefficient, heat transfer coefficient, length will be 2.5, then K thermal conductivity how much? 0.02966. So this value from there we will get H value. H is equal to how much we'll get? Nusselt number here you can write directly Nusselt number 422.3. So directly Nusselt number you can write. So H is equal to how much here? H is equal to we'll get here 0.296, 5.01. 5.01 watt meter square Kelvin. This is the unit. Now there has been calculated the heat loss per meter length. Per meter length of the pipe. So now we'll write the Q is equal to HA TW minus T infinity. This is the formula. H is equal to 5.01. So this is the 5.01. Then pi dl. I told here area is equal to pi dl. That only difference because they given here vertical pipe. Before and always solve the problem. Vertical plate. Plate means length into breadth. So pi into D dia 12 centimeter. So 0.12 So write meter like into, okay, product form write into pi 0.12 into length 2.5, because this is given 12 centimeter. 12 centimeter now we are making this is meter. So into per unit length per 1.2 meter per unit length they are asking, no? So heat loss per unit length, so 1, then 120 minus 20, so this value is coming 5.01 pi 1.2 per unit length, so this coming 188.8, so Q getting 188.8 watts. So this is they are asking calculate the heat loss per unit length. If they ask only heat loss of the pipe, then length will be 2.5 meter. But they are asking heat length per unit length. So that's why we will get the 188.8 watt per meter. So you can write here unit also watt per meter. Unit will be watt per meter. If they will ask here only heat loss na, this watt will come. So that time 2.5 meter only, this in place of 1 will write 2.5. Now per unit length na, length will be here, length per unit length will be 1 meter. Length will be 1 meter. This is area. Area is equal to pi dl. Okay. So this is the trick if they are asking vertical pipe. Okay. So okay students, watch this video, share this video to your friends and subscribe the channel to those not subscribe the channel, because you subscribe. If you will subscribe the channel, then only we will get the motivate and we will give the new video for you. Okay. Thank you.